So this is the objective of the concept is to find the differentiate between the lossy and lossless compression, calculate the compression ratio with respect to efficient compression manner. So nothing but to calculate the construction variable length coding using Huffman coding and execute the run length coding by binary data sequence, analyze the structural benefits of bit plan and gray level decomposition, and also identify the dynamic dictionary mechanism of LZW coding. So this is the basic explanation of lossy and lossless compression. So in generally, either the base lossy or lossless compression, during the data transmission, the input raw data is given to the source encoder and channel encoder. After that, it will be given to the data transmission technique. So in the data will be given to the source encoder. The source encoder has to identify the redundancy values and it will be removed in source encoder. In channel encoder, we have to accumulate the redundancy bit, nothing but we have to add the sum of the data will be insert during the transmitting the data for the data will be sent with errorless or not, to identify through the errorless or not. So this is the lossless block diagram of representation of lossless or error free compression technique, nothing but here the original signal is given to the encoder. In this encoder, it is considered as a channel encoder or and source encoder. So these are the two methods is used to compress. Next, the data will be decoded. Finally, the data will be reconstructed. Nothing but the x of n is nothing but equal to x cap of n. So nothing but here the example of perfectly reconstruction original data without a single loss of information. The target is a medical images, exact text and satellite data. If the image extension with respect to PNG or JPEG. So this is the to reconstruct the original data even with a single loss. So another, this is the block diagram representation of lossy, original data, encoded data, compressed data, decoded data. The reconstructed data is approximately to the input data. So that is the representation of lossy compression technique. It achieves the higher compression ratio by permanently discarding the imperceptible information. So this is, they have the some losses through the image compression. Maybe it achieves the high compression ratio. So this is the representation. So first we have to identify the core target of compression is to removing the redundancy or identifying the redundancy values. Here there are two methods, one is coding redundancy, another one is a spatial / interpixel redundancy. So here the coding redundancy, the pixel value is more than strictly necessary. The fixed length codings are inefficiently applicable to the variable probability symbols. So nothing but we have to use the Huffman coding. So the data will be represented in a different value of representation. So for example, the input in the form of so 0.4, 0.3, 0.2, 0.6 like that. So we have to identify the average bit error and also identify the probability representation of the data transmitted. So we have to fix the data transmission. So the variable data transmission method is available. We have to identify the repetitive and the higher order bit transmission will be fixed by using the Huffman coding. So another method is a spatial and intersymbol interference. So here we have to find the adjacent pixels share the identical intensity, creating high structural correlation. So whenever the adjacent pixels have the correlated pixel values, we have to identify it and we have to represent in a simple way. So this is the encoding techniques with respect to the code run length coding and bit plan coding.